So here's a few news stories. Um, if you use Windows, you can now run Linux directly on Windows with a Windows subsystem for Linux. And mostly they run Ubuntu there, but now they have developed a Kali desktop experience for Windows subsystem for Linux. So you might be able to run Kali there if you want to do that. I haven't played with it very much. People tell me it's gotten a lot better. In the earlier version, it was still going through the Windows drivers, so you didn't have any direct access to the hardware from Kali, so you couldn't use tools like Nmap or a lot of other tools. And from what I've heard, they fixed that. So this might actually be a reasonable alternative to virtual machine. So the CDC is still completely messed up. Trump got his crazy doctor, fake doctor from Fox News or somebody else equivalent ignorance to post a CDC coronavirus statement that was completely medically unjustified. And then the CDC retaliated last Friday by posting another one. But that one said what everyone I think has known for like 3 months to be true, which is that it is not just heavy, big drops of fluid coming out of people that sneeze, but it is these small particles that drift like smoke through a room that infect people with coronavirus. And that means essentially that if you could smell somebody smoking a cigarette, then you could get coronavirus from someone in those conditions. And that means that all indoor activities with a crowd of people are pretty much shot. And so somebody pressured them into taking that down. And it's been down for 3 or 4 days, waiting for some other document that is more approved to go up. So we are definitely far down what China was accused of doing with the first SARS crisis, and to a much lesser extent this time, of just publishing medical lies for the convenience of our administration who wants to pretend it's not happening. It is really quite distressing. Doesn't smoke, wasp, or whisk through the air? Yes, that's right. And so do the small particles from breathing and talking. And apparently those can carry coronavirus. That is what a lot of people have been determining for the last several months. And if that's true, then it's far more dangerous to be indoors. And I saw another article that said the 3 most common activities that they find that people engaged in who then test positive are going to bars, restaurants, and something else indoors. So just for a room, we're just sitting in for an hour in a room with other people who are just normally breathing and not necessarily coughing or sneezing is very dangerous. This is why I'm glad they closed our college, because sitting for a lecture hall in a college classroom is exactly another one of those activities that you really should not be doing. Anyway, so there's a critical Windows flaw. I've heard quite a bit about this. I haven't tried it, but apparently you can connect to a Windows server, and including a domain controller, and you can become administrator without passing through authentication at all. There was a similar one about Linux about 10 years ago, an R login flaw, where you could log in as administrator with no password. And so the federal agencies have been required to disconnect all their domain controllers from networks or update immediately. And people who use scanning tools like Shodan have found 20,000 machines still connected to the internet. So it's one of these. This is a 10 out of 10 security risk. These ones only come by every few years. MSO 867 was a big one. These ones where you can just totally take over a machine. And yet people say the exploit code that's out there to test it is not yet like a spreading worm. So it's not quite as bad as it could be. But anyway, everybody better patch their stuff right away unless they want to get hacked. I, of course, have not patched any of my stuff because getting hacked is good for me, but I'm a special case. The stuff that matters is not on Windows. So Trump is back to having his super spreader rallies where they're totally illegal activities in most of the towns where they are, but he just breaks the law and nobody cares. And he makes people wear masks when they're near him or when they're behind him where the cameras will pick up, and all the rest of the people refuse to wear masks. But this one's pretty funny. The same state, South Dakota, that held the gigantic rally with 500,000 people on motorcycles that then spread the virus all over the country, now had a huge rally hosted by the medical care company. This is Sanford Health. So you can go to the Sanford Health official super spreader event, and then you can go to the Sanford Health clinic to get treated after you get sick from it. It is, I think, the rest of the world is just amazed and horrified by the United States watching how incredibly stupid we are about this. And it is amazing. It's very much like watching people around you join an insane cult and go out there and worship a death god and have human sacrifices to their death god. and you can't do anything about it because they're all nuts. And it shows, I think, an important factor of psychology is that people don't actually decide very much in their based on logic in their life. What they mostly do is just stay in the herd. And if everybody's doing something, they just do whatever other people are doing. And they feel like it's right because they look at the people around them and say, well, I'm with the flock, so I'll be okay. And of course, most of the time, it is best to stay in the middle of the flock. Yeah. See, didn't Philadelphia suffer a huge second wave? Well, Philadelphia, the entire nation suffered a huge second wave of the 1918 flu, and I don't know if anybody ever decided exactly why. Some people thought that it was just the weather. Oh, well, I mean, when my servers get hacked, it's mostly because my students are hacking for homework, and if I get hacked otherwise, I just want to learn a technique. I went to DEF CON, and I got hacked. They got my Gmail account and they put me on the wall of sheep, and that was extremely educational. I learned how that worked. I spent the next year demonstrating it everywhere. So that's, I benefit from these things, but most people don't. I haven't ever had anything important stolen. My students have stolen. Yeah, it's a learning experience to get hacked. And by the way, if any of you want to hack me, go ahead. I have a policy for this, someplace, a disclosure policy. If somebody finds a weakness in my stuff, then I have a responsible disclosure policy, which says that, now, of course, you can't hack the college because I'm not authorized to allow you to do that, but you can hack my stuff. And if you hack in any of my stuff, then I am legally bound not to prosecute you, and you may end up on the Hall of Fame. I have a Hall of Fame for people who do something surprising here. About a dozen people have done it. From anonymous hackers on the internet to students and stuff, they've found flaws and gotten on my machines. Absolutely do it. It's worth extra credit. But of course, the disclosure policy says, you have to try to not disrupt the classes and stuff. And, but that's very good. And most companies are getting that way. They have a bug bounty program or disclosure program of some kind so that people that are not criminals can hack them and then talk to them without fear of being prosecuted. That's the point of this. It is difficult to explain to administrators, but your company is safer if you opt out of legal protection of prosecuting everybody who attacks you. The ones that come to you and discuss it and explain what they did so you can fix it need to be sure you aren't going to prosecute them. And by promising not to prosecute them, you become safer. But that's difficult to explain to administrators at first. Anyway, this one is kind of amazing. A guy working in the public relations department in the National Institute of Health has a secret identity as a right-wing troll spreading all kinds of lies about the coronavirus and about the National Institute of Health and about Fauci and everything. So he had a double life, doing one thing and the opposite. I've heard of this years ago. There are people who are like network security people by day and black hat hackers by night. So now that this leaked out, he retired from his National Institute of Health job. Twitter had a deal. You can put up a picture. And if you put a picture on your tweet, Twitter will somehow crop the picture to show only part of it in the preview. And what somebody tried and showed is that if you put up a picture that is got a black person in half of it and a white person in the other half, then it will always choose the white face and not the black face. And this is probably not an intentionally racist thing. The same thing happened to several laptop makers. They just have an AI and they trained it only on white faces. And they didn't consider that then their AI doesn't think that a black face is a proper way a face should look. But anyway, they're apologizing for that. The WeChat ban has been paused for a while, which is definitely good news for Chinese Americans who need WeChat. When I traveled to China, I found out what everybody knows. You can't get anything done without WeChat. It's the all-purpose application there, even more than Facebook is here. You use it for text messaging and sending money and paying for things and just everything. And not letting people here have it is a serious problem. So this guy was selling drugs, apparently not just marijuana, but also other drugs, because marijuana is hardly illegal anymore. And he advertised it this way. And so the cops just zoomed in on the photograph and got his fingerprint off it and caught him from that. So this is like people who let their keys hang from their belt. Modern photographs are high resolution enough that you can zoom in and make a copy of the key. Yeah. Oh, leaving fingerprints on mail. Yeah, I would think so. Yeah. So it's a thing to be aware of. You're exposing more in those fingerprints than you probably think you are. Anyway, so let's get down to the official stuff for 10 minutes after. And so that should be here. All right, so here we are. And today we're going to talk about IDA Pro, which will be And then I'm going to talk about some new projects. I've got a lot of new projects coming, and two I want to show you today that are really very nice. And I expect to have more next week because I'm continuing with the Flare-On contest, which is insanely difficult, but I'm learning a lot doing it. I still have only solved one challenge, and I have 1 point, but all my attempts to solve the second challenge for a week have taught me 3 or 4 projects worth of stuff. So I may never solve their exact challenge, but I'm learning a lot on the way. So let's talk about IDA Pro. So IDA Pro is the classic professional disassembly tool used by everybody. It's like Photoshop is. It's very much like Photoshop. It's what all the professionals use. It's also extremely expensive, extremely complicated and confusing to use, just like Photoshop. It's a serious professional disassembly tool, and you could easily spend years learning how to use it. And you can easily spend $5,000 or $10,000 buying all the features you want, and then you'll want like 3 or 4 high-resolution monitors, and you just spend all day picking through stuff. And that's what one of my ex-students did to find the iPhone jailbreak. He paid $5,000 to get the professional IDA Pro. He disassembled the iPhone OS and the boot up measures, and he found a new 0-day in the boot up measure of the iPhone, which led to the jailbreak check ring. Anyway, so now the pay version, very expensive, and not only is it expensive to buy, but then you have to pay more money to buy the plugins that reverse engineer code more. It does disassembly for the base price, but it doesn't do decompiling unless you pay thousands of bucks each to turn it back to source code. So, or something like that. I've never had these expensive pay versions. I've only heard about them. Anyway, there's a free version, which is kind of old, that only does 32-bit code, and that's what we're going to use so you can see how it goes. And of course, if you want to go beyond that, the next thing is Ghidra, which we've already talked about, and I may get back to writing more projects for Ghidra if I get done with the Flare-On stuff. Anyway, all right, so they've when you open this thing up, it shows you this thing, which is called graph mode, which is intended to make it easy to read the code, where you have these blocks of code, and every time you have a jump or an if, it shows arrows going to other blocks of code to try to make it easy to see where there's a loop and where there's a flow. The alternative is this one, which is what I always got used to seeing from way back in the old days on line printer paper, just long lists of instructions one by one, and then you would basically print this out on paper and draw these arrows yourself on it to understand it. So that's the assembly language description of a program, which of course contains the complete description of the program in the modern world, now that we no longer allow self-modifying code, but it is very difficult to read because it takes many assembly language instructions to do a simple thing, and it's a whole lot easier to read source code in C or BASIC or something. So anyway, this is the default display. Will look like this. You just have the instructions, and you don't have the address of the instruction, and you don't have the hexadecimal values of the actual encoded instructions. And this is not much use to me because I'm usually thinking about modifying a few bytes to change the program, or detecting the instructions and then searching for that pattern of bytes, or paying attention to what address I'm at and connecting it to some other address. So I like this, as I say in your book, turning on the line prefixes and opcode bytes. Make those adjustments, and then you have the same information here, but now you have, these are the actual bytes, and this is the address. One thing that's a little funny at first is that this program, in order to help you, adds a lot of comments to the code. So this address, 40140, this is the real address of this code where it starts, and this is the preamble where it creates a stack frame by pushing the old base pointer and calculating a new stack pointer to set aside room on the stack for the new temporary variables. But all these things up here are not actually machine assembly language instructions at all. These are just comments describing what's happening, and they give it all the same number. So this number is false, and all these are not anywhere in the code. These are comments added by IDA Pro to try to help you. So it tries to create a C header for this, and then some description of the arguments. All right, so there's colors all over the place, and we'll see these. So here, if you have an if statement, it's going to be a jump 0, jump not 0, something like that. If the condition is true, it follows the green arrow. If it's false, it follows the red arrow. And if you have a loop going back, I think it's blue. Or blue is an unconditional jump, and up is what makes a loop. So here's an unconditional jump. This is an unconditional jump blue, so there's just a blue arrow going here. This whole mess where you have a jump not 0, 2 choices, and then a jump is what an if is. If do something, then resume, skipping over that. Anyway, if you click one EBP, it'll highlight all the nearby EBPs and so on. It tries to help you. So if you click on something, it highlights all the other references to that on the screen so you can more easily see them to try to help you as much as possible to read this assembly code, which is notoriously difficult to read. You've got information on the text mode, which is the other mode. You can get here by pressing spacebar. And then it has comments created by IDA-Pro to give you some description. This is extremely useful. Here it pushes the offset of some string, and here it shows you, that points to a string, and it shows you the first 20 or so letters of the string. So you can see what's going to happen here. It's pushing a message about success internet connection. Instead of just having a meaningless numerical address, I can see right away what it is. It's going to print out this message somewhere. Here, it's a location here, and you can see where it's referred to. And here's a jump down, and here's a conditional jump down, or another condition. I'm not quite sure what the dash is conditional, solid is unconditional. It's what they say. Oh, I see, this is jump if zero. Okay, so that's a conditional jump down, and there's a hard jump down. So these are the arrows in text mode that are analogous to the arrows you'd see in graph mode. And by the way, these XREF things are extremely useful. You can double click these XREF things, which means this address here is referred to elsewhere in the code. And if you double click that, it'll show you where else it's referred to. That's extremely useful. And I was trying to use WinDebug again today and finding, as usual, that it is so broken as to be almost useless. It doesn't have these cross references. It makes it very hard to get anything done. Anyway, those are the auto comments. They're on by default. You can turn them off, but I would leave them on. They're really very helpful. And that adds comments to many of the instructions. The auto comments puts unnecessary extra comments on, pardon me, telling me it's a jump. I don't need that. I do need things like these cross references. Anyway, so here's some other windows. There's many other side windows. The functions window gives you names of all the functions and where they are, and information here, I forget what it is, telling you what kind of function they are. Then there's the names window, which is very nice. Every address with a name that's referred to somewhere, so it's going to be the names of functions or strings that are referred to. This is better than, say, bin text or the strings command that just finds any pattern of bytes that looks like a string. This finds real strings that are actually used in some way by being pointed to somewhere in the code, like OllyDebug's find all referenced text strings, which, by the way, is another thing that is completely missing from WinDebug and makes me very annoyed. So here's strings, looking at the strings out there, and tells you how long they are and where they are. And then you have imports and exports, of course. Most programs only have one export, which is where they start or main, and they have imports, which they import from various libraries. You see this one uses the WinINet library to get an internet function, and the kernel32 library to get some standard functions like what you might find in the C standard library, although it's in the world of Windows, so they're a little bit different. And you have a lot of data structures. You can see them all here, and if you hover over one of them, it will show you what it's built out of. A pointer here and a handler here and so on. It shows you cross references. You can double click in a function and it will jump to where it's referred to elsewhere. So it's really very handy, and we're going to use these. I'll demonstrate this stuff to work through a project a little later. So when you call a function in assembler, you got to get used to this. In order to call, here I am calling a function which is going to calculate the length of a string. So what you do is first you push the parameters on the stack. So here, to calculate the length of a string, the only thing you need is a pointer to the string. So here it pushes a pointer to the string. It calculates this number and pushes it on this, and then it calls this. That's how functions work. You put the data on the stack, which is temporary storage area, then you call the function, then the function looks on the stack to find the data. It does not know whether that was really put there. And this leads to format strings vulnerabilities we exploit in the exploit development class. If you call a function without first preparing the data on the stack, it will use random data that happens to be on the stack as if it was the data. And you can lead to surprising results and machine takeovers and such that way. So there's an option to reset the desktop to get back to normal, or save the desktop to save the view, because if you get all these windows set up, especially if you have a big screen, you can have a complicated setup that really matters to you. All right. So I often find when you load IDA Pro, you'll see this, it typically loads to some useless stub that doesn't do anything, and there's no easy way to get to the interesting code. This is one of the many annoying things, so what I always do is go to strings and find a string that I can understand, and double-click that to get to the code that uses the string. That's one way to find your way back to the interesting part of code. All right, you can double-click anything in one view and it'll take you to the other views that use it, which is very nice. You have forward and back buttons, just like a browser, which is extremely useful, especially when you're new to it. You click on things, and pretty soon you're lost in the weeds and you don't even know what's going on, and you wish you could go back, and you can go back, just like a browser, back to wherever you used to be. It's not like Ollie debug, where it's stepping through and forgetting the instructions. You're just looking at static code. The code is not running. So going back, all you're changing is the view on the screen, and it can remember how to go back in that. If you turn off a VM in Google Cloud, you will not lose your saved data. No, it's just like a normal Windows machine. When you turn off the machine, it remembers your installed programs and your data. If you have a program open and you haven't saved it yet, I think you would lose that. That's all. But you won't lose your saved data. Good. All right. So this thing here puzzled me at first. This colored bar. When you load a program, especially a big program, this will be not very colored, and it will take some time to color. And IDA is not done processing until all these colors have filled in. And the most interesting part is the dark blue. The dark blue is user-written code. The rest is things like libraries and numerical constants and stuff. The dark blue is what you probably care about the most. That is where you're going to find bugs and vulnerabilities. That's the stuff that was written by the developer of this particular program. All right. You can jump to a location with G and then just put in an address, and you can search. This is just like Ollie. It's got all kinds of good ways to search. Search for the next code, the next data, search for an immediate value, search for text, a sequence of bytes. You know, it's very nice. You can search for all the things you might need to search for. And then I mentioned there's cross-references. So if you go to a section here that just has a bunch of pointers, you can hover over this cross-ref thing, saying, and it'll show you right here in a little pop-up box the code that calls it. So this is main, and here's some code that calls main. So you can see it, and if you double-click it, it will just open that other window and let you examine it. So you can take a peek and say, well, what's using this? Is that interesting? That looks interesting. Let's double-click it. It doesn't look interesting. I'll just carry on and do something else. And you can press X to open all cross-references to this, see how many other functions refer to this. And since this is main, of course, it's only referred to by some part of the operating system that's launching the program, but other functions are probably called many times. You can go into functions. IDA Pro will recognize this as a function, and then it will create this fake header where it gives you the names of the pointers, argument 0, argument 4. It doesn't know names, but it knows how big they are and tells you that. All right, it's guessing, by the way. This is another thing that is pretty annoying. All disassemblers are guessing. They are not really running it in a real processor, and there is a whole game of anti-disassembly you'll see later on in the book. You can write code that will confuse the disassembler so it's wrong. The disassembler assumes that this code was made the way normal compilers make it. Ordinary compilers for C and C++ and all the other languages, Visual Basic, make common traditional assumptions of how to lay out the code, and IDA Pro assumes it's done that way. So if you write your own manual assembly code, or you write a malicious compiler, you can make code that will not decompile correctly. So just like I've mentioned about every tool in this whole course, you can't trust any of these tools too far, because the tools have bugs and the bad guys are deliberately making code that breaks your tools. So frequently, a tool fails you and you just have to go try a similar tool to get the job done, or a whole different technique. So you've got a bunch of graphing options here that let you have some kind of graphical displays of things. I've never used them much. I think they're perhaps out of date. There's some that are even marked legacy, a flowchart, function calls. Cross-references too is kind of nice. It shows all the paths that get to a function. I loaded the Windows calculator, and I put the cross-references. And one thing I thought was kind of funny is that it refers to check Windows genuine status. So apparently, some part of this code was going to check to see if you had paid for your Windows and somehow not let you use the whole calculator if you hadn't. I'm not aware of it actually limiting the functionality, but apparently they did include some code to allow that in there. Anyway, you can see the cross references from one code to another, functions that are related to others, and make various charts here, but I've never got much good out of that. But I'm not that deep into IDA. I've only done the simple things. All right. There is no undo. So there are some things that actually change these. Now, if you just look at an executable at IDA and close it and don't save it, you can use it that way. But normally people don't use it that way. Normally they spend hours, days, or weeks analyzing code, and they're filling it up with notes and marks and renaming things more descriptive names, and then it saves a file that has all those changes, and you don't want to lose those. So be aware of that. There's no undo in that regard. So you can change a name. It's going to start with names like this, sub 401,000. And if you figure out what that is, you can give it a descriptive name that means more to you, and when you change it in one place, IDA will upload it everywhere else, update it everywhere else, so you can gradually make the code more readable. What you're doing is manually decompiling, essentially. You're getting back to something like source code. But of course, that's a lot of manual work, and you don't want to lose it. So here's an example in the book. They have some examples, if you want to go through them, where you have something like variable 598, so you renumber that port. And here's argument 4, that's the string version of port, and this is the function that turns it into the numerical version, variable port, and so on. So you can rename arguments, and then they'll rename everywhere. And this is what you have to do if you want to get really deeply into analyzing a big block of code. So you can use shortcuts on the keyboard to make the comments. And of course, you can do them with the mouse. And by the way, if you have numbers, you can, of course, right-click them, and then you'll see the number in decimal, hexadecimal, octal, binary, and so on. You can trade it from one format to another easily. And if you use named constants, Windows API will fill them with the official Windows API names. There is a way to get the Windows symbolic constants in there. I'm not quite sure how you do it. I know in WinDebug, this is the one thing that's very good about WinDebug. Of course, WinDebug is tied into Windows, and you can connect it to Microsoft's official symbol set, and then it will have all the Microsoft official symbols, which is very handy to debug the kernel. As far as I can tell, the only time to use WinDebug is when you're debugging the kernel. I find it too difficult to use for user mode debugging, but some people learn to love it for everything. I'm not in that category yet. But when you're in the kernel, you got to use WinDebug. Nothing else works. And IDA, of course, like almost every tool we talk about, is a platform, and you can add more code to it, like Wireshark, like OllyDebug. The community people can add scripts to do all sorts of things, and you can import these scripts into your IDA Pro if you want it to have even more functionality. And we'll be using some OllyDebug scripts a little later in the demos. So let's take a look at this Kahoot, which is chapter 5, and here we are. All right, I'll give it a few more seconds. Some people are still coming. Okay. One, try 10. All right. What feature shows little boxes connected by arrows? All right, that's called graph mode. All right. What feature shows user written code as dark blue lines? All right, that's the navigation band. All right. All right, what kind of code cannot be disassembled by the free version? You can't do 64-bit code. There are other products that can, like Ghidra, but you don't get that for free in IDA Pro. All right, how do you switch from graph mode to text mode? All right, space bar. All right, how do you move to a specific address? G for go to. All right. So, right, and all right, Idaho will have to tell me who they are if they want their points. Anyway, all right. So let's take a look at the project that follows this. It's really pretty easy, especially if you use the Flare VM. Oh, I see Idaho tells me who they are. Good. So the first IDA project, which is the one I'll show you today, is here. And it is this one here, 303C. So I'm using IDA Free 7. There's an older and a newer version. This is the newer free version. And we're going to do labo501.dil. So let me just move this to the side, make it a little smaller. And then I'll bring up the window here. We'll need the whole window just for IDA. Now, you can do this in a Google Cloud machine and install IDA Pro on it, which is the way this project is written. But if you have made a Flare VM, IDA is already installed, just like pretty much everything is installed in your Flare VM. So here's the Flare VM. And so there's a Flare folder. And in there, you've got decompilers. Oops, not decompilers, disassemblers. And in there you got two versions, IDA Free, the old version, and IDA Free 7 is the newer version. So when you launch IDA, it always shows you this little picture, and then you can disassemble a new file, and you can browse to your file. And I've got the malware analysis samples on here. You'll need it on your machine too if you want to do my project. And so you open Labo501. It is a portable executable, and just say okay, and it will import it. So when it comes in, you see this colored bar up here that I talked about before, taking some time to process, and there's a series of messages going through at the bottom. This is sort of the log, and then you end up in graph view here, where you see bits of code. And here's what I always talk about. It just shows you some kind of boring system thing which loads the environment. And it doesn't lead easily to fun code. So anyway, in this case, what we're going to do is follow what they did in your book, and they're going to, first thing they're going to do is improve the look of this. This is the default look where it doesn't show me the instructions or the addresses. So you go into, is it edit options? All right, it's options general, all right. And here you can turn on line prefixes, and you can turn on some opcode bytes, like 6 maybe. And now you have addresses and bytes. And you notice these are really long addresses because this is a 64-bit operating system. So it's interpreting these as 64-bit addresses. Although IDA doesn't support 64-bit code, the addresses are labeled that way. Anyway, all right, so now I can go to text mode with the space bar. And you see the same thing this way. And now I want to find the import for the Windows API function that does DNS lookups. So I want to find imports. So it's view, open subviews, and there are a bunch of them, but the one I want is imports. And now I have a list of imports here. Now I can sort them and hunt through them. Another easy way to search is to just start typing. The name of this thing is get host by name in lowercase. So if I type get, that gets me down to it, get host by name. I wonder if I can make it bigger. I'm afraid I can't, but let me just spend a minute trying. View, options, fonts is grayed out, unfortunately. I wonder if general is going to give me, yeah, I may not be able to make this bigger easily, which would be nice if I could. Spend another second on it. If anybody knows, let me know in the chat. But I don't think it's going to be easy. The font is grayed out and so on. Anyway, so you double click get host by name, and now you get here. And I'm just going to take a look and see if I have it. Now I have a font option. Good. So let's make it a more readable font, like Lucida, bold, and 16. There we go. That's what I like. I knew at least parts of it you can make it bigger. So anyway, I wanted to find get host by name, and there it is. So when I click it, all the get host by names appear. All right, and now I think I follow the XREF. Let me just make sure I'm right. So I can find out where this is used by pressing Control X. It will now show me all the places where that's used. And it is, of course, a DNS resolution. So that's a pretty common thing wherever networking is done in this malware. I'm going to go to the one that says +101 just to follow the path of interest here. So now I am at the code in the text section. Remember, everything in Microsoft Windows is always named the opposite of what it is. So the text section does not contain readable characters. It contains machine language instructions. And this is the way to remember almost everything in the Windows world. So this is, here's get host by name. And now that's the assembly language instructions that use it. So I want to go back to graph mode. So I press the space bar, and now I can see here it is calling this function. So when it calls the function, it's going to calculate something and then push it up here. So it's pushing a pointer to that function, to some string. Then it's going to call this string. So that would be a domain name, which is resolved. And that's important because that would probably be my indicator of compromise. It could be the domain name of the command and control server that this malware goes to. So I would like to know what it is resolving. So I double click offset. Right, here's the value offset. It takes this value, then it adds 13 to it, and then it looks that up. So I would like to know where this is. If I hover to it, you can see in the yellow pop-up, this is RDO-PIC-Practical Malware Analysis. It is showing me the first 20 letters or so. So that is pointing to something that looks kind of like a domain name. And if I double click it, it will take me to the place where that data is referred to. And I think in this one, I just go to, I go to hex view. So here I am in IDA view, which is interpreting. It interprets the text view by turning it into assembly language. And in the data section, it just tries to lay out the data in a friendly way. But I might prefer to just see it in good old hex. And this is the address. Let me see if I can change my font again. That would be nice. Options, font, looks like I can. Good. Bold. 18 will probably do. All right, so it highlights this. This is an address in Little Endian order, 1001-9194. And that address, 1001-9194, is down here, and it's helpfully colored it in light blue. So this is a string, and you can see it. This is RDO. This was the 14 characters it skipped. And this is the real domain name, the command and control server name, pix.practicalmalwareanalysis.com. So I've now found an indicator of compromise by looking at the DNS resolutions, and that's the point here. All right, another thing I can do is I can find out the functionality of the program more. So if I go back and look at the strings, if I go View, Open Subview, and look at strings, I'll see the strings used by the strings found in this malware ought to appear. And where are they? View, Open Subviews, strings. Ah, there they are, generate a list of strings. Good, and let's see if I can make the font bigger again. It's grayed out on me this time. Anyway, the point is there is a string here that prints out the command line, and it starts with \\\. So if I just type \\/ twice, it takes me there, and I can see here this is cmd.exe/c, which is how you launch a command line command. So if I double click that, it takes me to where that is stored. And I'm still in hex view, just seeing the ASCII text that stores that string, but I'd rather see IDA view now, where I'm going to see not only that command, but now I'm going to see the cross-reference to see the code that uses it. And you see, here's the code. I get about 10 lines of code around it showing that it's going to push that offset and then do a jump somewhere. So if I double click this, it's going to take me up to that code. And now, if I close some of these other windows to get more real estate, I can see what's going on here. It goes here, it calls and gets a system directory. It looks up which probably the C Windows system directory to see if it is C Windows system or C Windows system 32. And depending on what it finds, it either calls the 32-bit command line, CMD, or it calls the 16-bit command line, COMMAND. So remember, this is old 32-bit malware, so it's probably considering that it might be running on a 16-bit system, like DOS or something. And that's the plan here. So this is apparently something that executes an arbitrary command line command. And so that's one thing you can see here. And if you just scroll up, and again, just like I mentioned with OllyDebug, when you're a beginner, you just look at the right. And the right is where they have easy stuff. So here I have command I can read. Here I've got stuff like startup info. If you just scroll up and look at what came before this, you will find readable menus up here that are passed on to the command and control. Hi, master. See, this is a bot, and the bot will talk to you with messages. So you take over the machine, and then there's a command and control server that's keeping track of thousands of bots, and it's sending a signal back. And in that control software, the command and controller can open a panel which then says, okay, would you like to send some traffic from it, execute a command on it, and so on. So here's Hi Master. So if I point to this, it shows me more text there, machine uptime, machine idle time, and so on. So if I double click that, it'll take me to other strings that are being used here. And I can see them this way or the other way. So I can see various messages that it sends. And I now have a pretty good clue what's going on. This is remote control bot software that can do various functions. Anyway, so there's a project here where you track down some of those things. And then there's a couple of crackmes. So let me figure out the best way. I think I'll just download one here and put it in by dragging it. So I save this in downloads. And I'll just replace it, crackme121.exe, show in Finder. All right, so I can just drag this in here. All right, and these are just simple crackmes I wrote. I wrote these based on a malware analysis class I took from the HoneyNet Alliance years ago that motivated me to write this course because it showed me that the modern tools made this pretty easy. So if you, first you want to see how this thing works. And in this case, I compiled this myself and I was pretty sloppy. So instead of telling you which Microsoft runtime library you need to install, I just saved the DIL file, which is a sort of cheap and sleazy way to do this. Here is the Microsoft portable C of whatever version you need. So now this should run. So if I open a command prompt, and then I go to the desktop, and then do a directory, there should be a crackme here, and there it is, crackme. So if I run the crackme, it'll run, and it gives me a usage message. I'm supposed to put in a password. So I'll put in a password of 1, and it says fail. put in password of 2 and fails. So that's it. This is a simple password guessing game. You have to find the right password. Now, a lot of the techniques that we've covered could pretty easily find this password. But we're going to do it with Ollie just for practice. And in the later ones, you might actually sort of need Ollie. So let's open it up in Ollie. File, open. I'm going to not save the database. They warn you here, because remember, you could have spent hours putting labels and stuff in this file, and it wants to save the database. But in this case, I'm not going to save it because I haven't done that much work. And now I'm going to open a new one from the desktop. Crack me. All right. And I'll just let it analyze it in the default way. And I don't really care whether, now it knows about getting Microsoft signals and so on. I'll just give it any kind of answer here because I don't really care about that stuff. All right. Now here I am. It's loading and processing. Note this bar is still gray, but there, it's finally, here's the blue. Right. And this is what I mentioned before. It loads some kind of procedural early stage on the way towards launching my program, which doesn't have any interesting code here. And I find this very annoying. So my solution is get rid of these things that are useless. Go to strings, view, open subview, strings. Because I played the game and I saw the game had something called fail. So if I look at these strings, and let me see if I can make them bigger. Nope, it's grayed out. Anyway, I can see here, fail, you found the password, congratulations. Good, right there it says fail. I saw that string when I was playing the game. So if I double click that, I'll get to where the word fail is stored. And if I point to this, I'll see some of the code. If I double click this, I'll get to the code. So now I found the code that up here, here's the code that where something starts. Then it has some kind of, here's where it has a usage message. So this is the part where it decides whether I put in 2 arguments on the command line or not. If I did put on 2 arguments, then it follows the green line. But if I didn't, then it goes over here and prints the usage message. So I see what the program is doing. Here, it refers to some string called top secret and does some kind of some kind of test, and then does a jump. And based on that, it either says you found the password or fail. So apparently the password involves comparing this string top secret. So it's pretty likely that top secret is it. Even without bothering to read and understand all the assembly code, I get enough clues here that I think the password is top secret. So let's try that. Don't save the database. And so if I go back to my command line and okay, that's the help message and top secret. So I win. So that's the point. And there's a series of these that get harder and harder as you move forward. So, and the last one frustrated me quite a bit. I didn't get the last one myself, not until they told us how. So they're increasingly hard as you move forward, but you get to practice reading code with IDA and figuring it out. All right. And so I'm going to stop this video and take a 10-minute break to process it. I'm starting again at 7. I'm going to demonstrate some new projects, and they're very new. I encourage you to stick around or at least look at the video later. So I'll